Imagine giving your microcontroller laser vision. Today we're making it happen with a Raspberry Pi Pico, of course, and a VL53L0X time of flight sensor. And I'm going to use a Waveshare touchscreen for demo purposes. This isn't just range detection, it's interactive, precise, and kind of futuristic. So whether you're prototyping your bots and droids or building sci-fi interfaces, this setup is surprisingly powerful and dead easy to integrate. We'll fire it up, walk you through how it all works, and show you why this tiny sensor punches way above its weight. Ready to get your hardware going and see the world? Well, let's go. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT, and other fun tech. Please remember to subscribe and join the community. If you like this video and it helps your learning or your projects, then why not drop me a cash tip using that super thanks button below the video, or there's a payment link in the description. And please hit the like button on the video and subscribe for more. Let me give a shout out to PCBWay, our sponsor. For makers like you, whether you're crafting robots that dance, building smart IoT gadgets, or tinkering with embedded systems, you know the moment comes when a breadboard just won't cut it. That's where PCBWay steps in. From precision PCB fabrication and assembly to sleek 3D printed enclosures, sheet metal work, and even CNC machining of aluminium cases, they've got your back. So if your ideas deserve a pro finish, PCBWay is the go-to crew to bring it to life. Check them out via the link below. They're helping projects like yours go from concept to creation. For my tests with laser range finding, I'm going to use a VL53L0, and these are small modules. In fact, the sensor itself is tiny. I mean, you can see it there on the center of my module. These are infrared lasers. They're also class 1, which means they're safe around human eyes, as I understand it. They're I2C devices, so we've got SCA and SCL broken out there. 3.3 volts devices, and you've got a digital shutdown called X shut there if we want to turn it off digitally from our Picos, and an interrupt pin which can actually trigger every time it's got a new reading. So how does these rangefinders work? Well, we've got our module there, and I've just drawn a little diagram of it in red, and we got our target in green. What you want to do, of course, is measure the distance between the two. So how do we do that? Well, the module sends out a pulse of infrared light as a laser, which strikes the object. It then bounces off the object as a reflection and is picked up by the sensor. And the sensor then works out by the speed of light how far away that is. It does several readings and then averages. In fact, we can give it different amounts of time, which allow it to use different strategies to get more and more accurate. Now, accuracy is an important point with these sorts of sensors. So the VL53L0 that I'm using is really in the 30mm to 2 meters range. In fact, I probably would say sort of more 30mm up to a meter and a bit. So, you know, it depends a bit on what your atmospheric conditions are around it. You know, if you're in bright sunshine, it's going to be a lot worse. If you've got lots of particles in the air, that's also going to affect it and things. There are other, of course, sensors that you could use if you want to go to the smaller end of that range. So if you want to go sub 30mm, something like the VL53L4 would be a better bet than the L0. And if you want to go bigger, over 2 meters, well, there's the 53L1, which will take you up to about 4 meters. And then there are a range of sensors that could go up from about 4 meters to about 10 meters. So I've written a couple of examples to go with this VL53L0X, and they're over on my GitHub account in this repo. One's going to be just working with a Pico, giving standard out messages, but it's kind of dull to demo. So I've also done one using the Waveshare RP2350 Touch 2.8, which means that you can see everything on the camera in one go. Now both of these I've used a library from Nick Spreen, and he's written a nice little C++ library to interface to this sensor, and that worked perfectly for the Pico. So how am I going to connect these Pico to my module? Well, of course we've got to connect up ground and 3.3 volts out of the Pico. It's not going to draw very much current, so it's fine to pull the 3.3 volts directly from the Pico. Then I want GPIO 4 and 5, and that's actually I2C 0, and that's what we're going to use and set up to communicate. So let's have a look at the code. So let's have a little look at test 1 example here, and this is a really simple example. I have built out a little CMake include file to build out a static library for the VL53L0X based on Nick's library that I've included over here. But really, let's just talk about the code. So I'm defining our two GPIO inputs for this. So we're going to use 4 and 5, which is going to be I2C 0. And all I really need to do is, firstly, I'm going to set up standard I/O and just print start. I normally put a sleep in there just to let things settle down, and then we can get going. So we need to initialize our I2C device, give it a speed that we want it to run at. We are going to set these two GPIO pins to actually have the I2C as their function, and we're going to pull them up. And then we can use Nick's library, which creates this sensor object here. We can initialize it, give it a timeout period, give it a timing budget. So the budget, this is really about how accurate we want the sensor to be, so how much time we want it to take to average and to get a good quality reading. And this is in microseconds, so I've given it plenty of time because I'm really only going to take a reading from it every second, so it can have plenty of time to get a good reading, and then we can do a reading. So I'm going to put it into continuous mode. This library allows continuous or instantaneous readings, but I'm allowing it to do it continuous, and then I can just read off the readings when they're ready. And then we got a loop reading them off. One thing here is you notice I've got a little bit of a constant here that I'm just taking off. You're going to have to calibrate this sensor for your setup, for how everything actually works, and that's important. So you're always going to have to calibrate it, always, because where you're going to put the sensor, how is it going to be positioned, etc. That differs from position to position. So you will have to calibrate it. I just put in a hard-coded value there, and I've done the same with the other example. So I've previously done a review of the Waveshare's RP2350 Touch LCD 2.8, which is this device here. Now, the nice thing about this is it's got a nice breakout for I2C there on a port with ground, 3.3 volts SDA and SCL. Now those are on different ports and indeed a different I2C device on the RP2350 than I've just used for the Pico example. So we're moving to I2C1, but that's okay. We just need to configure it like that. So I'm going to set up a demo where I'm connecting the sensor into this port. And then I'm going to use the LVGL graphics library that's available so I can have a nice big display showing the actual millimeters measurement. So the Touch 2.8 example is very much the same. I'm not going to go through all of the code here because this relies on LVGL, and that could be a whole series of videos in its own right telling you about how that graphics works. I will quickly talk about the minor differences, because setting this up and connecting this, we're on different ports. So we're on GP6 and GP7, which gives us I2C1. So I'm this time initializing those. I'm also creating the sensor as a global variable, a global pointer there, so that I can actually access it from multiple files. Not necessarily the best way of doing it, but it was a quick hack to get this up and running. And the other quick change from the previous example is when I construct our sensor object, our VL53L0, I have to now give it the I2C device, which is going to be I2C1, because it defaults to I2C0, and on this controller we're using I2C1. The rest of this just initializing it, and the actual bit that actually draws stuff is over here. So in the widget setup, I'm actually just placing a label on the screen in the center of the screen. I'm making it nice and big. Where's the font? Yeah, they are. Font size 46, so it's nice and big. And then I've got a little animation or timer code, which is calling back, which is getting the value from our sensor, and it's just updating it on the screen. That's what I'm doing. Okay, so let's do a test. And I'm going to move our block up to 200 millimeters and get a reading about 203 millimeters. So not bad, especially as I'm not sure whether I've got that entirely square. 150 millimeters, again, pretty close. Take it down to 100 millimeters. There we go. Again, pretty close. 50 millimeters. Now, as I get closer and right into the sensor, things are not quite so accurate, and things drift a bit, including my focus as well on the camera. Sorry about that. Using Nick Spreen's library made integrating this time of flight sensor a breeze. Honestly, most of my time went into getting this touchscreen display to work exactly as I wanted for the demo. There's a lot more going on with that than it looks. Check out the code. Next up, I'm going to be adding this sensor onto RexP1 as part of my new improved tilt mechanism. So stick around to see if that works. It's been a work in progress, that particular problem. If you like this video and it helps you out or sparks an idea for your own projects, consider supporting me with a super thanks below the video or through the payment link that's in the description. I'm saving these tips up to get myself to the open source conference in San Francisco, and every contribution brings me one step closer. I'd love to meet you there. Thank you again for watching. If you enjoyed this, then give it a thumbs up and make sure that you subscribe, because you don't want to miss the next video, do you? And if you want to know more about sensors and ideas for the Pico, why not check out this playlist here?